Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about word problems. So, if I was given this problem, working alone, Ryan can dig a 10-foot by 10-foot hole in 5 hours. Castle can dig the same hole in 6 hours. How long would it take them if they work together? Okay? So the first thing we want to note here is the work amount of Ryan, is Ryan's rate times the amount of time it takes him, which is 5 hours, okay? And little note to ourselves here, work is equal to rate times time, okay? And that R stands for Ryan's work rate. Castle can dig the same hole, the same work that is done, in 6 hours. So we have Castle's rate times 6 hours, and C stands for Castle's rate. So what we're going to do here is, well, they're both W, so we can set them equal to each other. R times 5, that's a 5 there, equals C times 6. And then from there, R by itself is 6/5 of C. Okay? Another thing we know they're asking us here is how long would it take if they worked together? Okay? So that work, the same job, would be their work rates added together, so R plus C times time. Okay? So now we want to see how we can simplify this a little bit. Okay? We're given here, we know that W is equal to Castle's work rate times 6 hours. So we can write that as C times 6 here. And we have also set it up to ourselves here that Ryan's work rate is 6/5 of Castle's. So we can replace that R here with 6/5 of Castle's plus another C comes down times time. Well, let's simplify. 6/5 C plus 1C, that's 11/5 C. So we have C times 6 equals 11/5 C times time. We're going to divide both sides here by 11/5 C. Okay? And we're left with, now this is tricky, right? Kind of how I wrote it, but the C's end up canceling, and so this whole, both parts canceling, and 6 divided by 11/5 is, as a decimal form, 2.73 hours. And that's the time it takes for them to do this job if they work together. Okay? Now, don't forget to subscribe to this channel here, and as always, can pour a large concrete driveway in 6 hours. Dan can pour the same driveway in 7 hours. Find how long it would take them if they worked together. Okay? So what do we have here? They tell us here that Shauna's work to do that job, W, is equal to, all right, her rate, which we're going to call S, times 6 hours. Okay? We also know that Dan can do the same job, okay, in 7 hours. So Dan, his work rate times 7 hours. Okay? So we can set them equal to each other because they're both equal to W. So we have S times 6, and I know my S's are weird. D times 7, or bad. Let me know down below if you think they're bad. Okay? But still like this video. Then from here, we want to get S by itself. Divide both sides by 6, and S equals 7/6 times D. So from here, where can we go? Well, we know that we want to find out really, actually, what it would be like if they worked together. So that same job, W, is equal to, well, Shauna's work rate plus Dan's work rate times time. Okay? And it should be a faster time. Okay? So what we're going to do now is adapt what we found here to here. Okay? Well, we know work is equal to 7 times Dan, or Dan times 7. And the goal here is really to get rid of the variable S and W. Shauna's work rate is equal to 7/6 of Dan's. plus Dan's times t. And we're just substituting this value in here. Okay? Now we want to solve for t. And this is going to be kind of nice. You'll see. D times 7 over here. Add these two together. And 7/6 plus 1 is actually 2.16 repeating times Dan. And then times t. We can divide both sides here by 2.16 repeating d. And the d's cancel, all right? And we're left with t by itself, which is equal to 3.23 hours. And we now know exactly how long it would take if they worked together. So don't forget to subscribe to our channel and like this video. And as always, thanks for watching. It takes Trayvon 10 hours to clean an attic. Cody can clean the same attic in 7 hours. Find how long it would take them if they worked together. Okay? So one thing we know here, our work here is equal to Trayvon's work rate times 10. Okay, for the 10 hours that they can do that work. And that same job Cody can do, so whatever his work rate C, he can do that in 7 hours. Okay, so since they're both equal to W, we can set them equal to each other. T times 10 equals C times 7. Divide both sides by 10, and T equals 7/10 times C. Okay? Now they ask us here how long it would take if they worked together. So that work, the same work, all right, would be if they work together. So T's work rate plus C's work rate times little t for time. Okay. And now we're going to substitute values that we know. We know that here W is equal to C times 7. And the whole goal is to try to get rid of some variables here. T, we know is 7/10 times C, which we set up earlier. And now we just have the variables 7/10 C plus C times little t. And now let's try to get t by itself. 7/10 plus a c plus 1c, okay, is equal to 1.7c times t for time. We divide both sides by 1.7c to get t by itself. And on this side, the c's do cancel. These cancel here. And we're left with 7 divided by 1.7, which is 4.12 hours. And that's left equal to the t that's left over here. So if they work together, they can do it in 4.12 hours. So I hope you learned something here. Please subscribe to our channel and like this video. And as always, thanks for watching. Alone, Carlos can oil the lanes in a bowling alley in 5 hours. Jenny can oil the same lanes in 9 hours. If they work together, how long would it take them? Okay, so this job, the work it takes, W, okay, Carlos can do that. So Carlos is right here, can do that in 5 hours. Jenny, the same work, okay, the same work, can do the same lane in 9 hours. So J times 9. Since they're both equal to W, we can set them equal to each other. So C times 5 equals J times 9. And let's get C by itself here. And C equals 9/5 of J. All right? So now we need to make another equation. The same work, if they worked together, we would add their work rates, C plus J, and multiply that by time. Okay? Now we already know that W is equal to J times 9, so we're going to replace that here, J times 9, equal to, and C is 9/5 J. Now this is designed from the beginning to try to get as little variables here as possible to eliminate some, and now we just have J's and T's, and now we're going to solve T for time. So the left, J times 9 is just by itself. But on the right, 9/5 J plus 1J is actually 2.8 J, mixing fractions and decimals, times time. We now divide both sides by 2.8j here. And we're left with t by itself on the right. The j's here cancel, okay? And 9 divided by 2.8 is a 3.21 hours. And so if they work together, they can complete this task in 3.21 hours. Hope you learned something here. Please subscribe to our channel if you haven't already and like this video. And as always, thanks for watching. Together, Paul and Daniel can pick 40 bushels of apples in 4.95 hours. Had he done it alone, it would have taken Daniel 9 hours. Find how long it would take Paul to do it alone. Okay? So we know work is equal to our rate times time. They tell us here the work is picking 40 bushels of apples. So that work, 40, okay, bushels of apples, is equal to, well, they said if they work together, Paul and Daniel, so P plus D, each one of their work rates, it took them a total of 4.95 hours, okay? Now, they said Daniel also, if he had worked alone, he could do it in 9 hours. So we know that work, all right, is 40 bushels. So a little note here, that 40 bushels, Daniel can do that in 9 hours. I think I'm still in. I'm going to move over just in case I'm not. So a little note here, we have 40 is equal to Daniel times 9. Okay. So, where can we go from here? Okay. Well, we know then that Daniel, okay, if Daniel is equal to 40 times 9, that means Daniel by itself, his work rate here is 40 divided by 9, which is a 4.4 repeating. Okay. And then, well, what do we know about, what's his name? Paul. What's Paul's work rate? Can we get something similar here? Well, Paul's work rate is, well, we have 40 bushels is equal to whatever Paul's work rate times time. So if we get P by itself, just so we have it, might be useful, is 40 over T. Okay, dividing both sides by T there. And this sometimes can help you. Sometimes it's good to try to put all your equations together and see how we can piece this together. Okay, well, I'm going to take this original one that we started here. I'm going to rewrite it and substitute what I can. We have 40 equals, okay, and what do we have? We have P plus D, okay? Well, D we know to be 4.4, right? His work rate is where 4.4 repeating, and P is 40 over T. So if we have 40 over T for the P value, plus Daniel, which is 4.4 repeating, and we have to multiply that by this time here, which is 4.95. We now have an equation that just has one variable t, and we can solve for that t. Divide both sides by 4.95, and we're left with an 8.08, like an 808 drum, hashtag Kesha, is equal to, what's left on the inside here, is 40 over t plus 4.4 repeating. We then subtract a 4.4 to both sides, and we're left with a 3.63 repeating equal to 40 over t. Now this is 3.63 over 1. We can essentially kind of cross multiply and divide. So we cross multiply, we got 3.63 times t equals 40. Divide both sides by 3.63, repeating. And we're left with a t value here of, pretty simple, just 11 hours. So if Paul and Daniel worked, if Paul did it alone, that's what we're solving here. If Paul did it alone here, his time would be 11 hours. That's it. So please subscribe to our channel if this helps you out, and like this video, and as always, thanks for watching. Working together, Jenny and Natalie can mop a warehouse in 5.14 hours. Had she done it alone, it would have taken Natalie 12 hours. How long would it take Jenny to do it alone? So a few things we want to note here. The work of Natalie, okay, so work is Natalie's work rate times 12 hours, okay? We don't know what Jenny's work rate, but we can label that as Jenny times T here, okay? So, one thing though, we do know, okay, I have my work on 2 pages here, so bear with me here, okay, is their work rate together, okay, they tell us that total job they can do together if we take their work rates, we add them together, in 5.14 hours, okay? So, now, what we're looking to do, okay, we want to substitute what we can. We know that work rate is equal to n times 12. Okay, it's a little different way to do it. We have, so n times 12 here, that same work is equal to j plus n times 5.14. Distribute that across to both parts here, and we have really, let's go right as like this, 12n is equal to 5.14j plus 5.14n. And let's try to get our n's together. We subtract 5.14 to both sides, and we're left with a 6.86n equal to 5.14j. From there, let's get n by itself, divide both sides by 8.16, and we're left with n by itself here is equal to 0.7493j. Okay? A lot of work there, but we have n by itself. So now let's go back into our equation and see if we can plug that in for n. Okay? So we have our work here, it's a W, is equal to j plus, this is n, but 0.7493j times 5.14. Okay? And we know in terms of j's and t, all right, j's and t, that Jenny's work, our work is j times t. So we have j times t here equals, we add these together, j plus 0. Oh no, why did I distribute that? Anyway, I ended up distributing these two together and then adding them together. So you can add them here. If we do that, we have, well, actually I won't distribute, silly. We have 1.7493j times 5.14. Now multiply that out. I don't know why I was doing it the other way. 8.99j, must not have been thinking earlier. Glad I caught myself. And we have j times t. So now, what's interesting, okay, let's look it up. We can see how it lines up. We have j times t equals 8.99 times j. Let's rewrite that. J times t is equal to j times 8.99. So what is t equal? Divide both sides by j, or they cancel out. And Jenny's time, we have 8.99 hours. And that's how long Jenny would take to do it alone. So if you learned something here, that's great. Subscribe to our channel and like this video. And as always, thanks for watching. Rob can tar a roof in 9 hours. One day, his friend Kayla helped him, and it only took 4.74 hours. How long would it take Kayla to do it alone? Okay? Some things we want to note here. And I have my work on another page. That, well, Rob, right? The work here that Rob does is Rob's rate times 9. So whatever that job is, it takes whatever Rob's rate is times 9. That same work is equal to Kayla's rate times T. We don't know what that is, okay? But together, we know that same job, W, is equal to R plus K, each one's work rate added together, right? They're working together, and it takes them 4.74 hours, okay? Well, where can we go from here? Well, we know that work is equal to R times 9. So R times 9 is equal to R plus K times 4.74. Okay? So now what we want to do is, well, what can we do, right? We want to distribute this 4.74 to both sides here, and we have R times 9 equals 4.74R plus 4.74K being distributed. Let's get the R's together. So I subtract 4.74 to both sides, and we're left with a 4.26R equal to 4.74K. So let's get R completely now by itself. Divide both sides by 4.26, and R is equal to 1.11267. Okay. So where can we go from here? Okay. Well, we know work is equal to R times 9. So our work here, is equal to R, which is 1.11267 times K, times 9. Multiply that 9 times 1.11267, and we got work equals 10.01 times whatever K's rate is. Rewrite this around, W equals K times 10.01, and that's our time we're looking for. So we have 10.01 hours, and that is how long it would take Kayla to do it alone. Hope you learned something here. If so, please subscribe to our channel and like this video. And as always, thanks for watching. Working alone, it takes Kristen 11 hours to harvest a field. Kayla can harvest the same field in 16 hours. Find how long it would take them if they worked together. So let's go write down what we know. That work, whatever it is, right, that field work, is equal to Kristen's rate times 11 hours. We know that same work is equal to Kayla's work rate, so we'll call that A for Kayla's work rate. Don't want to put two K's there. And it takes 16 hours there. If we combine these two, we have K times 11 equals A times 16. And we can do that because they're both equal to W. Getting K by itself, K equals 16 over 11 times A. They ask us here how long it would take them if they worked together. So that same work together, we add their work rates, K plus A, times T here. Okay? Well, we know that work is equal to A times 16. So we have A times 16 is equal to, now K we also found to be 16 over 11 times A, 16 over 11A plus 1A times T here. Add this inside together, inside the parentheses, we simplify. A times 16 is equal to 16 over 11 plus 1A, which is 27 over 11A times T. From there, we divide both sides by 27 over 11A, and be careful here. The A's cancel. This number cancel here, 27 over 11, and 16 divided by 27 over 11 is 6.51 hours, and that is equal to our time. And so we have our answer. If they worked together, it would take them 6.51 hours. I hope you learned something here. If so, subscribe to our channel and like this video. And as always, thanks for watching. Crystal can wax a floor in 16 minutes. One day, her friend Perry helped her, and it only took 5.76 minutes. how long would it take Perry to do it alone? Well, let's go find out. Our work here, whatever that job is, that work takes Crystal's rate times 16 minutes. Okay? Perry helps her one day, and they did it in 5.76 minutes. So we can set up the formula. W equals, we add their two work rates together, K plus P, times 5.76 here. Okay? Well, we know that work is equal to K times 16, so we have K times 16 here, is equal to K plus P times 5.76. Okay? We can distribute that 5.76 to both parts here, and we have K times 16 equals 5.76K plus 5.76P. And our goal is to see if we can, simplify this somewhat, right? So we'll bring our K's together. We subtract 5.76K to both sides, and 16 minus 5.76 is a K times 10.24, and that's equal to 5.76P. Okay? We divide both sides by that 10.24, and we're left with K by itself here is equal to 0.5625P. Take that K, and we know that's equals here to this K. So our work is equal to 0.5625P times 16. Multiply this number times 16, and let's rearrange it. So we have P comes first, times 0.5625 times 16 is actually 9. And now we have it set up for work for Perry, and so our answer is just 9 minutes. And it will take Perry 9 minutes to do it alone. If this video helped you, please subscribe to our channel and like this video. And as always, thanks for watching. Working alone, Dan can sweep a porch in 15 minutes. Alberto can sweep the same porch in 11 minutes. If they worked together, how long would it take them? So our work here is equal to Dan's rate times 15 minutes. The same work, all right, we have Alberto's work rate is multiplied by 11 minutes equals the total job that's done, which is sweeping the porch. Well, combine them together, we know that Dan times 15 equals Alberto times 11, right? We basically set them equal because they both are equal to W. And D by itself is 11 over 15 times A. So we need to know how long it would take if they worked together. So the same job, that W, is equal to adding both of their work rates here times time. Well, W we know is A times 11. And Dan we have in terms of A, which is 11 over 15, A, plus another A in times our time. Well, let's simplify inside. 11 fifteenths A plus 1A is equal to 26 fifteenths A times T, and we have A times 11 still here. We divide both sides by 26 over 15A. These cancel, variable A cancels, and 11 divided by 26 over 15 is a 6.35, and that's minutes here, is equal to our time. And that is how long it would take them if they worked together. If this video was helpful for you, please subscribe to our channel and like this video. And as always, thanks for watching. Ryan can paint a fence in 10 hours. Asanji can paint the same fence in 8 hours. If they worked together, how long would it take them? So what can we do? We need to set up some equations here. We know that our work here, which is painting the fence, Ryan, whatever his rate is, he can do it in 10 hours. That same job, W, takes Asanji at his rate times 8 hours. Okay? We can combine these two together because they're both equal to W, And R times 10 is equal to A times 8. And R by itself is equal to 8 over 10 times A. And you can simplify if you want to, but I'm going to leave it like this so we can see it. So we know if they work together, our W here is equal to the rates of each one added together times time. That's them working together. Well, we know W is equal to A times 8, so we have A times 8 here. And Ryan's work rate is equal to 8/10 of Sanji's. A plus A plus times T, excuse me. Well, we can add them together. 8/10 A plus 1A is 18 over 10 A times T. And we have 8A here. Then we want to get T by itself. Divide both sides by 18 over 10 A. The A's cancel, these sides cancel, and we're left with T by itself. And 8 divided by 18 over 10 is 4.44 hours. And there we have our answer. It's how long it would take if they both worked together. It's 4.44 hours. I hope this video was helpful for you. If so, please subscribe to our channel if you haven't already and like this video. And as always, thanks for watching. Alone, it takes a Sanji 8 hours to dig a 10-foot by 10-foot hole. Brenda can dig the same hole in 9 hours. How long would it take them if they worked together? Okay? So let's go dive into this. Our work here, which is digging a 10-foot by 10-foot hole, which is a pain in the neck, is equal to Asanji's work rate times his time, 8 hours. That same hole, W, is equal to Brenda's work rate, B, times 9 hours. We can set them equal to each other because they're both equal to W. And we have 8 times A is equal to B times 9. A by itself, divide both sides by 8, is 9/8 B. So now we want to find how long it would take them if they worked together. So that same job, W, 10-foot by 10-foot hole, is equal to their work rates added together times time. Well, we know W is equal to B times 9. That's a weird looking B. There we go, a little better. And A is equal to 9/8 B. We add B here and multiply it by T. Okay? Now we just have B's and T's together. Let's try to get T by itself. Add what's inside the parentheses, and 9/8 plus B plus 1B is 17/8 B times T, and we have B, a better looking one, times 9. Well, we want to get T by itself. Divide both sides by 17 over 8 B. These cancel. We're left with T by itself, and the letter B cancels here. So 9 divided by 17 divided by 8 is 4.24 hours. And there we have our answer. That's how long it would take them if they worked together. I hope this video was helpful for you and you learned something. If so, please subscribe to our channel and like this video. And as always, thanks for watching.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.